Yeah, so hi everyone, I'm Raghav, and in this PCD, we will discuss all the problems of Div 1. Basically, in Div 1 and Div 2, there were same problems. So, this is the video tutorial for starters 159. So, we will start on with like all the problems in Div 1 and Div 2 are same. So, let's start with the very first problem, elections. The problem says that there are two candidates, A and B, who are contesting an election across n states where n is odd, and a candidate wins if they receive more votes than the opponent, and the candidate who wins in more than half of the states wins the election. So, in the ith state, candidate A has received AI votes and candidate B has received BI votes, and chef has the power to cast x votes. He can distribute these votes among the multiple states to help candidate A. We have to determine if these additional x votes could secure enough state victories for candidate A to win the elections. So the problem is just saying that there are two candidates, A and B, and there are n states. In each state, elections will occur, and in the ith state, candidate A got AI votes and the candidate B got BI votes. A candidate can win in a state if AI is greater than BI, then candidate A will win. If AI is less than BI, then candidate B will win. And if both of them are equal, then nobody wins. Now, our goal is we want to win greater than equal to basically we want to win more than half of the states. So if there are 7 states, we want to win at least 4, and you can win a state by making sure that the number of votes you have is greater than the number of votes the opponent has. So we just have to tell if, like, we use the chef's power, who can cast these x votes in different cities as he wants. So basically, let's say if x is equal to 10, if chef is having 10 votes to cast in elections, then what he can do is he can increase the votes of candidate A or candidate B as per his choice and increase it by some amount. So the results of the election in that state may vary after the changes made by chef. So we have to tell if we like, can chef make sure that the candidate A wins? Maybe we can take one example. Let's say if the elections are like this, 315 327. So 315, and this is 327. So the votes which the candidate A got in the elections in 3 states were 3, 1, and 5. And similarly for the candidate B, the votes are 3, 2, and 5. And chef has 3 votes which he can uh, give in different elections of these states as per his choice. He wants to make sure that candidate A wins at least half of the states. So basically, you want candidate A should win 2 states. Now, in this state, um, both of them are at draw. So if the chef gives 1 vote here, then you will secure this state. For this state, you want to give, like, here candidate A is 1 vote behind candidate B. So if you give 1 vote, then the votes would become equal. If you go give if you give 2 votes to candidate A here in this state, then the number of votes of candidate A would be greater. So candidate A can win here if you get 2 votes. Similarly, here candidate A is 2 votes behind. So if candidate A gets 3 extra votes, then he can win. So these are the extra number of votes which candidate A needs to win for these respective states. And our man chef is having 3 votes which he can distribute at different places. So what he can do is he can distribute one vote here and two votes here. So he would exhaust his three votes in this way, and chef will win here and here. He will lose here, but we only wanted to win at two places. So this is one way in which you can make sure that candidate A will win. So please tell me, is the problem making some sense of what we had to do in the problem, and are you getting some idea? At least tell me whether the problem is clear or not after taking the example as well. Okay, nice. So till this point, we were only discussing the problem statement and taking an example to understand what is the problem. Now, if we talk about the logic part, there is at least one thing very clear, that if for some state the candidate A is having more votes than candidate B, then you won't interfere here. है ना? I'm talking about the intuition part or the basic trivial observations, the bare minimum thing which you should notice. If candidate A is already winning, in that case, you should not interfere. If the number of votes are equal, then you can make candidate A win by just giving one vote. Similarly, if not, if let's say candidate A has 10 votes and the candidate B has 15 votes, then you would require to make the number of votes of candidate A to 16. Basically, you would require 15 minus 10 plus 1 number of votes to make sure that the candidate A wins in this state. This is the bare minimum you need to do. And we can just formulate that for any state, when AI is greater than BI, you are already winning. Otherwise, BI minus AI plus 1 is the number of votes chef will have to use in order to make sure that allies, sorry, not allies, but candidate A wins in the ith state. This is the bare minimum, right? So let's say if there were three states, in a state the candidate A is having 4 votes, 6 votes, and 8 votes, and let's say candidate B is having 5 votes, 9 votes, and 10 votes. So what do you think? No matter, like, or maybe if I'm having x equal to 5, let's say, then what do you think? Where should I use these votes? Try to think about it. You have, let's say, half a minute. Try to think about it, that we know if A is winning somewhere, you don't do anything. If A is not winning somewhere, you know how many votes you would require for A to win in that state. Now, obviously, you can use that knowledge to find out the number of votes you require here. Like for the city, for the state one, you can use 2 votes here. For here, you would require 4 votes, and here you would require 3 votes. So, what do you think? Where should I use these votes? I believe it should be intuitive, that you should try to invest these votes in the states where A can win with less number, like with less help. Like you should not invest these votes at a place where you require a lot of votes to be chipped in order to make A win, because whether A wins here or here, it doesn't really matter. What matters is A won at some place. So you would like to invest at the places where A requires less help, right? So can I say, with the help of the array A and array B, you can create this, let's say, array C, and then sort the array C. You would have it in a way like 2 3 4. You don't really care about the state which require 3 votes for winning. You only care about these values, and then you can go from left to right and invest one by one. If you manage to reach the half of the part, if you manage to reach till half of the part of this array, then A can definitely defeat B. A would have been able to win half of these states. But while going from left to right, if you realize that the value of x depletes and it goes below 0, in that case you know that you can't have A win. है ना? So guys, is it clear? Do you think you understood the problem, basically the intuition behind solving the problem? In case if somebody has somebody is having any doubt, then feel free to ask it. I might have missed something, so if I have missed something, then please mention it in chat. I hope this is clear. So okay, so if it is clear, then let's go to the code. So in my code, what I have done is, first of all, I took the inputs and I just sorted the array. Instead of creating a new array with name C, where I put up this B minus A plus one thing, I just sorted the array on the basis of the second array value minus first array value. And then I went over this sorted array. In case, like initially, when you have sorted the array, the initial values might be the states where A was already winning, and then you will have the states where A was losing. Just 1 second. Yeah, sorry. So basically in my code, first of all, I'm checking that if A is already winning without any help, then increment the answer and just move on. And if at any place I realize that when A is not winning on its own, I will give some votes so that A wins in that state. And if I realize that X goes below 0, it means that you're not having that many votes in your bank to make A win. So in that case, I will just break off the loop. Otherwise, I will implement the answer and go into the next iteration and repeat the same process. And eventually, you would like to have this answer, that is the number of states you have won, being greater than equal to half of the number of states which were there. So shall we move on to the next problem? Okay, great. So here is the next. Here is the second problem. Okay, just 1 second. Okay, yeah, I think now it's better. So spend 2 minutes, try to read the problem and think about what to do. Okay, let me also read the problem. So it says that chef is playing a game where he starts with some initial health edge and it decreases in battle. So let's say if chef's current health is P, it will drop down to D after the fight against a monster, and he wants to defeat as many monsters as possible. So if his health was P, it will drop down to D, where D is the largest divisor of P other than P itself. The game ends when chef's health reaches 1. Before starting the game, chef can multiply his initial health h by any integer m, which is in the range from 1 to k, and he wants to maximize the number of monsters he can defeat. So he would choose a value of m so that h into m make sure that he can defeat as many monsters as possible. We have to determine the maximum number of monsters chef can defeat if you choose the optimal value of m. Let's take an example. If you had 3 and the value of uh, m can be as large as 6. So yeah, let's understand the problem first. Chef is initially having his health is h, and he can multiply his health by any number in the range from 1 to k. So let's say he chose the number m, then his health will become h into m, and then he will play the game. So at any point of time, if let's say chef is having his health as p and he plays a game to play against the monster where p is greater than 1, then his health will drop down to d, where d is the largest divisor of p other than p itself, other than p itself. So whenever you see something like this, largest divisor of something other than the number itself, or you see you have to do something related to the second largest divisor, then uh, you should always uh, remember that for any number x, its second largest divisor would be x divided by the lowest prime number of x, basically the smallest prime number divisor of x. So let me explain here what I mean by it. Let's say if there is a number x equal to 12, then all of its divisors would be like, you would have studied about this method in school. If you have to find out all the divisors of a number, you can find it like 1 into 2 12, 2 into 6, 3 into 4, है ना? So all of its divisors are 1, 2, 3, 4, 6 and 12. The largest divisor other than 12 would be 6, or you can say the second largest divisor. Basically for any number, the number itself is the largest divisor. So if you say the largest divisor other than the number, you are talking about the second largest divisor. So you have to find out, let's say, this value, the second largest divisor. So the second largest divisor multiplied with the smallest prime number would be equal to the number itself, है ना? So you can say that the second largest divisor is nothing but the number itself, which is x, divided by its smallest prime number. Here at this place, you would always have the smallest prime number. Obviously, it cannot be something like 4, because if it was 4, then um, there would be contradiction. Na? Kyunki, if you have a 4 here, then on the other side, whatever number you have, just saying 2 into the double of that number would always be better. So basically, you would always have a prime number at this place, and it would be the smallest prime number. Um, so you can always say that x by the lowest prime number or the smallest prime number of x. This would be the value for the largest prime number, sorry, the largest divisor of a number other than the number itself, or the largest proper divisor. So guys, first of all, tell me that are you with me till this point? Many people might not know about this already, and many of you might have already seen this. I even discussed this a few weeks ago in a PCD, and I think in that PCD I had spent more time at explaining of why it comes like this. So if anybody has any problem till this point, then please mention it. Otherwise, I think we can move on. Okay, great. If nobody has any problem, so I hope you got the point that whatever number you had, let's say you had the number h, maybe let's say h is equal to 24. Then after playing a game, this h will drop down to 24 divided by its lowest prime number divisor, so which is 2 in this case. So 24 will become 24 by 2, which is equal to 12. Then after playing another game, basically after defeating another monster, 12 will drop down to 6. Again, it is divided by the smallest prime number it has. After that, it would be divided by again its smallest prime number. It will become equal to 3. Then for 3, its smallest prime number, uh, wait, we had to divide it. Yeah. So for 3, its smallest prime number is 3 itself. So it will become equal to 1. Like for 3, it is a prime number. In this case, you had two divisors, 1 and 3. So the second largest prime number, sorry, the second largest divisor is 1. And as soon as you reach 1, you can't play any more games. So for initial health 24, you would have been able to defeat 1, 2, 3, 4 monsters. Right. Now, if we talk about a case like 3, 6, in this case, in the best possible answer, your initial health was 3. You could have multiplied this. The value of k here is 6. So you could have multiplied it with any number in the range from 1 to 6. Let's say you multiplied it with 6. Then 3 into 6 will become equal to 18. Now for 18, 18 is equal to 2 into 3 into 3, right? 18 is nothing but 2 into 3 square, or you can say it as 2 into 3 into 3. So after playing the first game, the lowest prime number would be removed. It will, like, the health will become equal to 9. Then this would be removed, health will become equal to 3. Then this would be removed and health will become equal to 1. I hope you got the idea that you can just find out the number of prime numbers when you like if you prime factorize the number, then the number of prime numbers you see, that is the number of monsters you would be able to defeat. So in this case, you would be able to defeat 3 monsters, and for any other value from 1 to 6, you won't be able to defeat more than 3 monsters. So the answer would have at the end be equal to 3. So are you guys with me till now? Till now, all I have discussed is that for any number, after playing one game, your new health would be equal to that number divided by the smallest prime number it had. So if you say that there is some there is some number x equal to p1 raised to the power s1 into p2 raised to the power s2 into p3 raised to the power s3, then the number of monsters you would be able to defeat is nothing but s1 plus s2 plus s3. This is my claim. And um, if formula is looking complicated, then just try to have a dry run. Let's say if you have a number like 2 into, like, 2 square into 3 raised to the power 4 into 5 cube, then after playing one game, the health will become equal to 2 raised to the power 1 into 3 raised to the power 4 into 5 raised to the power 3. Then after another game, it will become equal to 3 raised to the power 4 into 5 raised to the power 3. Then after 4 games, it would be 5 cube only. After 3 more games, it would be equal to 1. Hai. So you would be able to play 9 games. That is 2 plus 4 plus 3. So overall, we can just say that whatever health we initially had, if you prime factorize it like this, then the number of monsters you can defeat is nothing but the sum of the powers. Sorry. Now, the problem would have been simple if k was equal to 1. Basically, if you could not multiply the health with anything big. But we are not that lucky. We can multiply a number with anything between from in the range from 1 to k. So we will have to figure out the best possible value so that we can increase our chances of killing more monsters. You know, as we have noticed till now, that the answer does not really depend upon the prime numbers. Instead, it depends upon the powers, right? So you would like to pick up a number in which you have a very big, like you have as big powers as possible, so that when you multiply the this k with the number, with the health you had initially, let's say you had the health as h, and you multiply it with some value m which is equal to p2 raised the power, let's say p2 raised the power 4 and p3 raised the power 2, then h into m will become equal to p1 raised the power s1 into p2 raised the power s2 plus 4 into p3 raised the power s3 plus 2, है ना? So these powers would at the end be added, whatever powers you had. So you can just say that my answer would be nothing but s1 plus s2 plus s3 plus whatever is the best health I can find out, um, which can defeat as many monsters as possible. So the best possible thing you can do is just try to find out as big as number as possible which is having only 2 as the prime numbers, है ना? Let's say if k was equal to 35, then you could have chosen numbers like 3 into 5 as m, sorry, you could have chosen a number like 35 which is nothing but 7 into 5, right? Or you could have chosen m equal to, let's say, 30 which is 2 into 3 into 5. Or you could have chosen m equal to, let's say, 34 which is 2 into 30, 2 into 17. Or you could have chosen m equal to something like 32 which is 2 into 2 into 2 into 2 into 2. I hope you can see the difference. If you choose a proper power of 2, in that case you are likely to have a lot of powers, right? You will have 2 raised to the power 5 here. You will have prime 5 prime numbers here. Whereas in the other cases where you are having bigger prime numbers, the number of prime numbers in the prime factorization is less. The powers here are 111, which is giving you just 3. Here you are just having 2. Here also you are having only 2. So picking up a proper power of 2 makes sense. So I hope you can just figure out that I should find out the biggest 2 raised to the power y such that it is less than equal to k. And here you just want to find out the largest possible y for which 2 raised to the power y is less than equal to k. So your answer would at the end will become equal to s1 plus s2 plus s3 which you had got from health, plus y. So guys, are you with me right now? Does it make sense on what value we should choose for m? Like we have figured out a way for choosing a value of m, and we have already identified on how you can find out the number of monsters someone can kill. So now the method is simple. Uh, After taking the inputs, you can just divide the number, whatever health you had, just divide it by its lowest prime number as long as the value remains greater than 1, and increment the answer. So basically you have figured out the different prime numbers, um, the total number of prime numbers which are dividing the health, and after that you can just find out the largest possible value of y, so for which 2 raised to the power y is less than equal to k. So I have written it like this, but you can write it in the other way as well, where you initialize x with 1 and just multiply it with 2 again and again as long as it is less than equal to k. This is optional. So I hope this problem is clear. It is very doable right now, I believe. And shall we move on to the next problem? Can you explain code once? Oh yeah, there is one. Sorry. My bad. There is one more thing in the code which I forgot to discuss. For finding out the lowest prime number, uh, how will you do it? Where's my pen? Yeah. So if you have a number x and you want to find out the smallest prime number which divides x, one way to do it is run up a for loop from 2 till square root of x, run a for loop from 2 to x, and whichever number divides x, like whichever number you find out first which divides x, that must be the smallest prime number divisor of x. And if you don't find any divisor of x in this range, in that case x must be a prime number itself, so its lowest prime number divisor would be the number itself. So this is a way in which you can find out the smallest prime number of x, smallest prime factor of x. The This approach takes big O of n time complexity, sorry, big O of x time complexity, which is not very efficient. Let me check if it can work. Yeah, the number here is not too big, so this approach would actually work here. This approach would work here because the number is not too big, so I would suggest you to do this. The other thing is you can use the sieve of Erasto. I don't know what is the complete thing. Sieve of Erato, whatever that crazy name is. You can just use that algorithm, which can help you to find out which can help you to create this lowest prime number array in big O of n log n. So I don't think I should explain this part of code, because if you know about Sieve, you would be able to understand it very easily. You would already know about it. And if you don't know about Sieve, in that case, you should just go and search Sieve on internet and see about, like, understand it first. And from wherever you try to understand that, this thing will make sense completely. So for now, you just need to know that it works in the go of n login time complexity. And inside my code for every test case, I'm first of all taking the inputs. Then I initialized a variable x with the value h, and uh, divided it with the lowest prime number it had, uh, as long as the number is greater than equal to 1, greater than 1. So this would actually tell me the number of monsters you could have killed if your health was just h. And after that, I'm having this while loop which will find out the basically I'm doing it in the other way, in the reverse way, other than finding out the largest value of y such that it is less than equal to k. Instead of going from 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and so on, I'm saying that I would just divide k by, like, I would just divide k as long as I can, and at some point of time k by 2 raised to the power y will become equal to 1. So it means that this is the largest value of y such that 2 raised to the power y is less than equal to k. And as soon as I divide k by 2 raised to the power y plus 1, it will become equal to 0. है ना? So the way in which I'm finding out the largest value of y such that it is less than equal to k is by dividing k by 2 again and again, as long as the number stays greater than 1. And at last I'm printing the answer. Okay, so somebody has shared this code and asking me something related to it. Um, I would look at it after the PCD. Is it fine? Once we are done with the session, if I look at your code. Okay, nice. Okay, so does anybody have any doubt related to my approach for this problem, or should we move on to the next problem? Great. So the next problem is chess coloring. In this problem, it says that we have a chessboard of n into n size, and we have to determine the number of ways to color exactly n square by 2 squares black, such that no two black squares share a side, and two ways of coloring are considered different if there exists at least one square that is colored differently between them. So the problem is like, let's say you have a chessboard of 2 by 2 size. Here n is equal to 2. So if you draw this cell with black color, then you cannot draw either of these cells with black color because they share some side. So you will have to draw this one black, है ना? And if n is even, then n square by 2 is nothing but half of the cells. So it means that you will have to, oops, sorry. Yeah. So you will just have to draw all of these cells one by one. You will have to draw these cells black one by one, and for the remaining cells, they will remain white. So this is one configuration, and the other configuration would be to draw this one as black. Let's say I decided that this cell should be black. In that case, I will have to draw this cell is black. This is my only choice, and the others will remain white. So this is the other way of painting them, right? Now my claim here is, even if you had a 4 by 4 grid, if you had a 4 by 4 chessboard, since you have to draw half of the cells in black color, so let's say if this corner is chosen to be black, in that case you will have to, like, you can't draw this one as black, you can't draw this one as black, you can draw this one, you will draw this one, then you can't draw this one either, you can't draw this one either. I hope you're getting the idea that you will have a pattern like this one. You will have to choose these cells, right? And these would be white. And the other possibility was, for all the cells which have been colored white right now, you could have colored them as black and the others could have remained white. So right now, what I want you guys to notice is the observation, the main observation for n is, like, for n being even is, if you decide one of the cells, any one of the cells to be black, you don't really have a choice for the other cells, because you can't color the adjacent ones as white. You will have to color the diagonals one as black, otherwise you won't be able to color half of the cells as black. So you will have a pattern like this one which we have right now. So guys, is it making sense, or is it looking like not intuitive. Please tell me in chat of what do you think for this approach. Yeah, what I'm saying is if n is even, then in that case n square by 2 is exactly the half of the number of cells you have, so you won't really have any choice right now. And when n is odd, in that case n square by 2, like we have n square by 2, the floor of n square by 2, so it would be less than it would be less than half. Like if n is 3, then n square is 9 and n square by 2 floor is 4. So you will have 4 black and 5 white. So there can be more ways there. But if you have to color, in this case, like where you have 16 squares and you have to color 18, sorry, 8 of them as black, then you don't really have a choice. Either you have to color them as black or you will have to color these as black. Now let's say if you had n is odd, then in that case, for a grid like this, if you color this guy as black, you can color this guy as black, you can color this one as well, and you can color this one as well, and this one as well. This is the maximum number of cells you can color as black. And for the other ones, you can't color them black because they would be adjacent to the black cells, right? So here we are able to color more than half of the cells. Like we had to color this many cells as black, which in this case would be 4 black and 5 white, right? So out of these 5, you can keep any 4 of them as black and one of them can become white. You don't really have any conditions for the white cells. So out of these 5 cells, basically out of the n square by 2 seal, this many cells, which in this case is 5, you have to choose 4 of them to be black, the 5th one will become white. So these are the number of ways for choosing 4 black cells. If you consider that this corner will be black, because as soon as you consider this corner to be black, this must be white, this must be white, this can be black, this can be black, this can be black, this can be black. Hai. The other combination is if you chose this guy is black, this guy is black, this guy is black, and this guy is black, in that case you don't really have any choice now. Like this is just one combination you have. So the answer must be equal to 5c4 plus 1. Now this 5c4, basically this is nothing but n square by 2 seal, and this is n square by 2 floor. So this value would always be 1 less than this. So you can just say, like you can think of it in this way as well. You will have n square by 2 seal of n square by 2 number of choices that you can color any one of them as white. Out of these 5, you can just color any one of them as white, so that you will have 4 blacks remaining. So this particular thing can be rewritten as n square by 2 seal, right? N square 2 by seal, combinations of n square 2 by floor is equivalent to saying n square by 2 seal. Choose one. You are choosing one of them, which you will color as white. So this is the answer. So guys, is it making sense, or is it looking complicated, or do you think it didn't feel intuitive enough? Please give your feedback. In case if you feel that this is not intuitive enough, then I will explain it again, or I will try to explain it in some other way. But I think it should be doable right now. Okay, intuitive. What about others? Odd part once more. Okay. Okay, so let's say n is odd, then Devansh, out of these 9 cells, just pick up any one of them of your choice. 1357. I was asking for one only. So let's say you chose one. You chose to color this guy as black, right? Then in that case, you can't color either this guy or this guy. है ना? From the even case, you would have already noticed that the cells you can color would be in diagonal. है ना? Would be diagonal to each other or coming up at distances of 2, right? So the cells which you can color black are this, 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 and obviously if you choose uh, like this as well, right? If you try to think about choosing this guy and this guy, then you would be doomed because choosing any of these, like if you are choosing this guy, then obviously you can't choose this or this. And if you choose something like either of these, then you won't be able to, like you would get these people sacrificed, है ना? You would get more people, more potential cells being sacrificed. So obviously, like this should be good enough for you to get the idea that you cannot choose any of the white cells. For you can't color any one of these cells. Okay? Now, out of these 5 people, you only want 4 of them to be black, and one of them can become white. है ना? So you are having n square by 2 seal this many cells, out of which you can choose one of them to become white, है ना? And the others will can stay black, right? So these are the number of ways for you to choose one of the cells to become white, so that you will have 4 cells remaining black. Or you could think of it in this way, that you can choose 4 cells out of these 5 cells. In that case, you would have got a formula like this one: n square by 2 c divide c n square by 2 floor. Or you could just directly think in the way that color any one of them as white. Nextly, you had this, like if you had chosen any one of these black cells as a cell which you would definitely color black, then you would have got this combination only. But if you had chosen a cell like this one, then you would have said that, hey, I can color this, I can color this, and I can color this cell is black, and I can't color the other cells as black. This is the only way for me to get 4 black cells, right? Okay, so now you're asking about understood NCR, but how do we get seal? Okay, so you're asking why am I applying a seal here, right? If you had 9 cells, half of them, like one less than, uh, see, if you have 9, 9 by 2 does not, 9 by 2 is not a, not an integer. And in any matrix of odd cells, of odd size, you would have some cells like this one and some cells like this one, right? So if let's say the total number of cells is 9, then these cells which are sharing the corner and the center would be one more than the others. Like this is something you can maybe understand with dry run. I'm struggling a bit to think of some easier way for you to notice this. Are you able to notice this right now? That if you had, let's say, 9 cells, then 5 of them would be similar to each other and 4 of them would be similar in parity. Like these are having the same parity for row plus column mod 2. This is also one common observation. Yeah, so basically these, the count of these cells will come out to be n square by 2 floor, and the count of these cells will come out to be n square by 2 seal. You can just understand it with dry run. I think that would be the simplest way. So do you still have some doubts? Uh, I would say if you still have some, then please don't hesitate. Feel free to ask. Or if anybody else have any doubts, then you guys can also ask. Okay, great. So let's move on to the next problem then. Oh yeah, first of all, let's look at the code. I'm just taking the input and then I have been printing. If n is even, then I'm printing 2. If n is odd, then I'm printing n square plus 1 by 2. Basically, this would be the seal of n square by 2 and plus 1 for this combination. Fine. So let's look at the next problem. Random them. This problem is a bit tricky, but not difficult. It just looks confusing on the very first glance. The problem says that Alice and Bob are playing a modified version of the NIM game. There are n piles of stones, where ith pile contains AI stones. In each turn, Alice and Bob uh, rolls roll a fair D-sided die. The player who rolls the higher number gets to make the move. If they roll the same number, then Alice will make the move. During their game, a player must select exactly one non-empty pile and remove at least one stone from it. Okay, let me repeat it. During their turn, a player must select exactly one non-empty pile and remove at least one stone from it. The player who makes the last valid move wins the game. And given that both players play optimally, calculate the probability that Alice wins the game. So the problem is like you have, let's say, 5 piles where in the first pile there are 5 stones, then 7 stones, 10 stones, 12 stones, and 4 stones. There is a D-sided die. Basically, it has D faces going up from 1 till D. Both Alice and Bob will roll the die, and whoever gets the larger number will make a move. In their move, they will choose any non-empty pile. Let's say they chose this and remove 1 stone from it. So the number of stones in the pile will go down by 1. Whoever removes the last stone out of all of these piles will be the winner. So we have to tell what is the probability of Alice winning. Alice winning. So is the problem clear? Okay, great. So the only main part of the observation, sorry, the only main thing in the problem which you had to observe was it doesn't really matter whether like, let's say there are these number of stones in the piles 5, 7, 10, 12, 4. Since only 1 stone would be removed from one of the piles, and the winner depends upon who removes the last pile, sorry, who removes the last stone of the last pile. It doesn't really matter how many stones are available in the piles, right? And you might notice that even this doesn't matter whether Alice removes the first move for the first stone or Bob. At the end of the day, maybe let me show you a dry run and then it will make more sense. Let's consider this case. There are 2 piles, 3 and 9, and the die has 3 faces. So basically the die can have a number from 1 to 3. So yeah, there are 2 piles, 3 and 9. So there are a total of 12 stones. Now in the round one, in the turn one, Alice and Bob will both roll the die, and the one who gets the larger number will remove one of the stones. Now let's say Alice won. Alice got a larger number and he won. She won. And she removed a stone from this pile. And then the turn two will start. In the turn two, you will do the exact same thing which you did just now. You will again, both of them will roll this die. Whoever gets the larger number will choose one of these piles and remove 1 stone. Right. So, did it really matter whether Alice removed the stone or Bob removed the stone? Would it actually create any difference for the next turn, or would it actually have any impact on the answer? Try to think about it. This was the main observation, that it doesn't really matter who won the first round, who won the second turn, who won the third turn, and so on. At the end of the day, one stone would be removed from the piles. Again, it doesn't really matter in which order it gets removed, because our winner depends upon only the last stone. Whoever removes whoever removes the last stone, or whoever makes the last valid move, will win. So at the end of the day, there would be only 1 stone left. At that point of time, whoever wins that uh, competition of die, whoever gets the larger number, would get to remove the stone and be called as the winner. So guys, does it make some sense that the piles of stones doesn't matter? The number of stones also doesn't matter. All that matters is who removed the last stone. So for the first, let's say there were X number of stones. So for the first X minus one number of stones, whoever removed them, it doesn't really matter. What matters is in the last turn, who removes that stone. So yeah, after every turn, for the next turn, the die is fair. Whatever happened in the last move does not change the probability of who will get to remove the next one. So the problem is indirectly asking you to just find out what is the probability that, let's say, if this uh, the number Alice got by rolling the die is X and the number Bob get was Y. So the probability of X being greater than equal to Y, you just have to find out this thing where X comma Y would be in the range from 1 to D. And this is pretty simple because if X is equal to 1, then Alice can win only when Bob gets 1. If Alice got 2, then she can win only when Bob gets either 1 or 2. Similarly for 3, Alice can win only if Y is equal to 1, 2 or 3 and so on. So for X equal to 1, there is one possible way for winning. For X equal to 2, there are two possible ways for winning. For X equal to 3, there are three possible ways for winning. And in total, 1 plus 2 plus so on till D, there would be D into D plus 1 by 2. This many possible ways for Alice to win. And the total number of ways in which the game can go is for all the possibilities. Like if Alice got 1, Bob could have got anything in the range from 1 till D. If X got 2, Bob could have got anything in the range from 1 to D. Similarly, for X equal to 3, Y could have been anything in the range from 1 till D, and so on. So, for all the possible values of X, there are all possible values for Y. So, the total possibilities are D into D, out of which Alice will get the uh, advantage. Like Alice would be able to make a move. So, the probability of Alice making the move is D into D plus 1 by 2 divided by D into D, or you can say it as just cancel out D and D. So you got D plus 1 by 2 into D. You have to find this out. And you will have to print it in this format, like whatever format P by Q you get. You have to find out the modular multiplicative inverse of Q. Let's say it is Q inverse. So you will have to output P into Q inverse mod 1e9 plus 7. So you need to have the knowledge of finding out my modular multiplicative inverse. You need to know about it for solving this problem. If you don't know about it, then you can just search about uh, CP for maths in one shot. This is a video created by Utkarsh Gupta, and it is a really nice video, and he has explained it very well. So you can either watch it, and there is one more thing you can do. In my code, I have used a structure in which you, even if you don't know about this, you can still solve the problem. So will the parity of stones matter? No, the parity of stones won't matter. So like in my code, I have used this structure with the name mint. This is a very common thing. You might have noticed competitive programmers like Tourist or Jiangli using it, as it can, like if you use this struct, then in that case, uh, you can just write your expression in the same way, and uh, the struct will take care of everything, like the way of multiplication or the way of dividing. For that, it internally finds out the inverse and all, so you don't really need to worry about anything in that case. Just 1 second. Yeah, sorry for the inconvenience. So in this problem, what I have done is, first of all, I took the inputs, and yeah, I'm first of all taking all the inputs, and the answer is nothing but the yeah, I could have actually written it as d plus 1 divided by 2 into d. So it could have been written as d plus 1 divided by 2 into d. Okay, I can't submit it right now. No? Anyways, this expression will work. Uh, I had submitted with this expression and it did work. So what expression I have written here is, till this point, d into d plus 1, that is this sum n variable, and divided by d into d, divided by d into d. So this is a simpler expression which we could have written d plus 1 in d plus 1 divided by 2 into d. So that is what I'm doing. And this meant thing is just typecasting an integer into the mint structure, and then I'm just printing this p. So I hope this problem is also doable now. Yeah, by the way, in case if you didn't know about mint, then it is worth to look at the structure and try to understand it. You don't really need someone else to explain this to you. You would be able to understand it on your own. And uh, nextly, you can just implement it. There is nothing else to worry about. So this problem was a bit tricky. They were giving you some redundant information to make the problem look complicated, but in reality, the problem was simple. Shall we move on to the next problem? Or does anybody have any doubt in this problem? Why is it not depending on values? Okay, good doubt. See, if the piles were like 5, 3, you know, or let's say even if the piles were like 1000, 2, or even if the piles were like 9999, what will happen is whoever wins the first turn will remove one of the piles of either of these. Then again, a fresh die would be rolled out. You know, I had written it somewhere. Yeah, you would roll the die again to for the next turn. You would just repeat the same process again and again. You know, eventually the piles will, like, there will be only one pile remaining having only one stone. Now the one who removes this would be declared as the winner. Everything that happened till now does not depend, like does not matter for finding out the winner. So that is why I said that the piles does not matter. Like the piles of stones we have, or the number of stones we have, or the parity of stones we have does not create any difference, because the winner depends upon only the last stone. Whoever removes the last stone will win. And for the last uh, for the last one as well, the die game will be the same. Alice will roll a die. Now she might get one, she might get two, she might get three, and so on. So out of all the d into d possibilities, there are d into d plus 1 by 2 such combinations where Alice is having her score greater than equal to 5. So Alice will win. Um, like she will have a probability of winning as d into d by in d into d plus 1 by 2 divided by d into d. So does it make sense now? Okay, so somebody said yes, but how many times we roll the die depends upon some. Exactly. For each stone, like if you have 9999 number of stones, you would have to roll the die this many times, one by one. But the probability of Alice removing the last stone does not change upon the number of times the die was rolled out. Like even if this value is initially 1, or even if the value is initially this much, it does not create a difference, because eventually when this value becomes equal to 1, it doesn't matter what happened earlier. At the end of the day, you will just have one stone remaining, and the game would be as simple as it was on the first turn, that you will roll a die, Bob will roll a die, and if the score you got is greater than equal to y, then you will remove the last one, otherwise Bob will remove the last one, and the winner would be decided. So the winner does not depend upon this. Okay, great. So if this is clear, then let's move on to the fifth problem. Now, when we are discussing the last four problems, these are on the difficult side in comparison to the previous problems we have seen till now. So I would go a bit faster in comparison to the previous explanations. And I think that the ones who would be coming up to this problem would be either higher 4-star rated or the 5-star rated coders. So uh, they don't need much help either ways. Like I won't have to explain each and every step. So this problem says that chef is watching the new season of Squid Game, where contestants face a glass bridge challenge. The bridge has M steps, and in each of and in each step consists of two glass panels suspended side by side. So it is like yeah, you can think of it like there are N people, there are M steps, step 1, step 2, step 3, step 4, step 5, and so on. For each step, you are having two choices. Either step here or step here. Either step here or step here. Now, since you don't know, like one of them would be good. If a person steps on this, it will remain intact. But the other one would be faulty. If you step here, you will fall down into a pit or something like that. Since you don't know which one is good, which one is bad, you will just choose randomly, obviously, right? You would have a 1 by 2 chance of going here, or 1 by 2 chance of going here, since both of them uh, are random. Like there is complete randomness on which one would be faulty. So the game says that there are n people. They will go one by one. The first person will either come here or come here. Now let's say if the first person came here and fell into the pit, then the next person won't be dumb enough to go into this place again, he will go here for sure, right? He won't sacrifice his life just because he saw his friend to die right in front of him, right? So the problem is telling you that there are n people, they will go one by one. Now, if somebody died here, obviously the next person should ideally be smart enough to go to the other glass. And let's say if some person went to this class and then he went to this place, and let's say he fell into the pit, then the next person would be smart enough to know that, hey, I know at least how to go till this place, and after that I know that there is a pit here, so I won't go there. I would go to this place, right? And then again there are two choices and so on. So you have to tell what is the probability that all the n people will die on the first step itself. Let's say it as, yeah, basically you just have to find out the probability that all the people will die on the first step itself. So then you have to find out the probability that all the people will die till the second step, or till the third step, or till the fourth step, or till the fifth step, and so on for all the m steps. So does the problem make sense? Okay, great. So uh, yeah, basically the observation here I think is, like, what looks intuitive to me, at least it looks intuitive to me in the first glance, is that for any step there can be at most one death. If a person, let's say, chose this step and had died here, then the people who will come in future are not dumb enough to die at this place. They will survive, है ना? They will go here and then they might die on the very next step, but again at most one person will die here and the others would survive. So for each and every step, either nobody will die or one person will die. There can be no other possibility, right? Does it make sense? This was the main observation for this problem. At every step, either zero persons, either nobody will die or one person will die. And as soon as you see the zero one thing, like either nothing will happen or something will happen, then again either nothing will happen or something will happen. You are having two choices every time. Probably you should get the choice. You should uh, get some idea for zero one knapsack. Like it should feel intuitive that this problem is similar to zero one knapsack. So one in like one prerequisite is you should have seen something like zero one knapsack till now. Secondly, you should have some knowledge of probability. Elementary level is enough. And you should know about how to take care of overflows. So you should know about some basic maths for CP as well. For this basic maths of CP thing, I would recommend you to watch Utkarsh Gupta's video. That one video can make a huge impact for you for your future contests. For probability thing, you can maybe go to Eric To's channel. He has made a video on probability, so maybe you can watch out that video. And for zero one knapsack, you can go to Stiver's channel. He has created a video for this. If you are good to go with all these three prerequisites, then move on with the uh, with solving the problem, with the part of solving the problem. So the thing is, oh yeah, by the way, this is a DP thing. So the thing is, let's say let's say dp of I J is the probability of J people dying, J people being dead in the first I steps, right? Uh, the reason behind this trait is, since you have m steps, obviously you would like to have one of you would like to have one dimension for I, basically the number of steps you have already covered. Nextly, you care about the people who are dead, and at every step, either the number of people who are dead will remain the same or it would increase. So you would like to have j as a dimension, the number of people who are dead till now. So this can be a state. The base case would obviously be dp of 0 comma 0 to be equal to 1. There is one possible way that, sorry, the probability of nobody being dead for the first 0 steps, basically at the place when nobody has made any moves till now, everyone is alive, so nobody is dead. So the probability of dp00 would be 1. dp00 should be equal to 1. Nextly, let's say you have covered these I steps and you know that j people are alive, sorry, j people are dead. On the very next step here, either the person will die, either this person who is gonna move to the I plus 1 step will die. So dp of I plus 1 j, if a person dies, then this state, where which says that among the I plus 1th, sorry, in the first I plus 1 steps, j plus 1 people are dead. This state would be achieved. Like, this state should get some increment of dp of I by j by 2 because there is a half of a chance that all the people, like the probability of people being dead till now, let's say it is this, the probability of j people being dead among the first I steps. So the probability that j plus 1 people will die in the I plus 1 steps should be nothing but, or maybe I think I can change the way of telling you about the state. Okay, let's do it again. I hope all of you were with me till this part where we had discussed the states. Now let's see the transition for j people being dead among the first I steps. Either j minus 1 people would have been dead among the first I minus 1 steps, and there is half a probability of the next person being dying. So basically, among the first I minus 1 steps, j minus 1 were dead. Then there is half, like whatever the probability is, let's say the probability is x. Then there is x by 2 probability of j people being dead in the first I steps. Similarly, it is also possible that um, among the I minus 1 steps, like for the I minus 1 steps, j people were already dead and nobody died here. There is again a half of a probability. So this would be the probability of j people being dying in the I steps. We have covered both the transitions, that you nobody might die or one person might die. So this is the pull dp here. If you write the transition in push dp, then it would be dp of I plus 1 j plus 1 being incremented by dp of ij and dp of I plus 1 j being incremented by dp of ij. If you're comfortable with pull dp, then go with this. If you're comfortable with push dp, like in my case I do prefer push dp, then go with this kind of a transition. um, this is a lot simpler to think. This kind of transitions are a lot simpler because for the given state dpij, you knew there were two possibilities. On the next step, a person might die or a person might not die. The probability of the person dying on the current step is 1 by 2. So dp of ij by 2 would be added for these. Similarly, there is a case that dp of, let's say if j is equal to n, let us say that among the first 10 steps, all the people are already dead. Then in the next step, another person can't die now. If in the first step all those idiots are already dead who came to the game, maybe not idiots, but they might be getting some good rewards for playing the game. Let's say that all of them are already dead. Then on the next move, nobody can die now, right? So the transition for this case would be, if j is already equal to n, dp of I plus 1 j would be incremented by just dp of ij. Here the probability would be 1 because nobody else can die now. We don't have that many people to die. So you just had to apply this dp thing. And the way in which I explain this dp transitions and states might look very weird to a lot of you. This is just a way in which I approach the dp problems. So you, in case if it didn't make much sense, in case if you feel that it is not looking very intuitive, then you can look at the text editorial. The text editorial might have some better way of explaining the dp states and transitions. So either go to that, and yeah, we just had to solve it in this way, and the answer at the end would be uh, dp of 1n, all the n people dying on the very first step, dp of 2n, dp of 3n, and so on. You will just have to print all of these and so on till dp of mn. So guys, how many of you are with me right now? Just say yes. And if you are already lost, then tell me, where did you get lost? Okay, you are with me right now. So let's move on to the code part. Here, here also I use the mint data structure, the mint struct for uh, just writing the normal expressions. So here the way in which I have written the DP is, uh, basically I have written the iterative DP directly. So, and it is space optimized as well. So I think you should just look at someone else's code then. This might look complicated to some people, but if you know about space optimized DP, then you can have a look at it and try to understand it, uh, or maybe just skip it. It's not good to look at someone else's code, at least this much. Uh, just an overview is that for each and every state, I'm checking if j is less than n or not. If j is less than n, then I'm having these two transitions as I discussed here in push TV part. And if j is equal to n, and then in that case, I'm having this transition. So in my code, instead of having dp of I plus 1, I'm having uh, ndp, and instead of dp of I, I'm just writing dpi, sorry, dp, and at the end I'm just setting dp equal to ndp, and answer of I equal to dp of n. So uh, I'm storing all these variables inside a variable answer, and at the end I'm just printing this answer variable, all these probabilities stored inside the answer. So if you are able to understand the code, then very well. But I would advise you to try to write the code on your own. If you are comfortable with recursive code, then write it recursively first. Once you are done with solving the problem, and then if you want to look at my code and try to understand the way I have written it, then maybe it's good to look at my code. Otherwise, just move on. No need to look at someone else's DP code. Or it's better to look at the grandmaster's code. So let's look at the harder part of the problem now. The problem which we solved just now was the easier version. The harder version has tighter constraints. Here, five, like the constraints earlier were as large as 2 into 10 raised to the power 3. So even our DP state, like this one, which had like 2e3 into 2e3 states, that is 4e6 passed. But now we are having the constraints to be a bit tight. NNM can go as large as 5e5. So if we try to implement the previous approach, we will have like 25e5, which is some 25e10, which is something like 2e11 as the number of iterations, which will definitely give you TLE. So you will have to do it in a more optimized manner. So I will tell you the way in which I solved the problem. This was considered to be the harder problem, and solved. The number of submissions were comparatively low. My idea for solving the problem was, if let's say there are m steps, then the number of, like the probability of someone dying till the first, maybe let's say 10 steps, is nothing but the probability of the person dying on the 10th step itself, or if he would have died earlier, right? The person might have died earlier on some step before now, or he could have died just now, right? Now for the probability of the person to die just now on the mth step or the 10th step, is that in the first 9 steps, let's say if there were a total of 7 people, then 6 people should have died already. Does the game actually kill, or am I killing people for no reason? Okay, the people fall and die. Yeah, the people actually die. Yeah, so the people are actually dead. So what I'm saying is, if you want to find out the probability of all people dying in the first 10 steps, है ना, when you are talking about the first, among the first 10 steps, you would have already found the answer for the first 9 steps. The probability of someone dying on the first step, the probability on dying on the second, dying on the third, dying on the fourth, and so on, right? So the answer of 10 is nothing but the answer of 9 plus probability that the person die on the 10th step, right? Answer of 9 is the, like, answer of 9 would tell you about the probability of person dying among the first 9 steps, right? And then you are adding the probability that the person would die on the 10th step. Now for someone to die on the 10th step, uh n, like if there were n people, then n minus 1 people should have already died among the first 9 steps, and then on the 10th step the person must fall on the wrong place and die. So the probability of 10 is simple. Among the first 9 steps, 6 of them should have been fatal, where a person died, and after that, uh, he had two choices, so he must have picked up the wrong choice, right? Right. And okay, I should tell you a different way. So okay, till now, let's see. We wanted to find out the probability of someone dying among the first 10 steps. So for that, we identified that for a person to die among the 10 steps, we can say it as the probability that the person died among the first 9 steps. That is this answer 9, plus the probability of person dying on the 10th step itself would be the answer for 10. Now the probability for the person to die on the 10th step would be the probability. Okay, so the probability for 7 people dying on the 10th step would be nothing but the probability for 6 people dying on among the first 9 steps multiplied with 1 by 2. है ना? Now for the probability of 6 people, uh, actually these two are different. These two are different. Let's say we just want to find out the probability that the last person dies on the 10th step. It would be nothing but the probability that 6 people are already dead among the first 9 steps, and then the misfortune happens for the last survivor and he dies on the 10th step. Yeah. Now what is the probability that the that 6 people died among the first 9 steps? So it is nothing but uh, see, there were two choices, there were two possibilities every time for the, yeah, maybe let me just confirm it. Yeah, so what I think is there were these 9 steps. Every time there were two possibilities, a person might die, a person might not die, person might die, person might not die, person might die, person might not die, and so on. है ना? So if you want among these 9 steps, 6 people should die. So there are 9C6 ways for the people to be dead, and the total number of ways were 2 raised to the power 9 here. So 9C6 divided by 2 raised to the power 9 would be the probability for 6 people dying among the 9 first steps. and then you say that another person will die. So there is half probability of that happening. So this is what I added. So my formula came out to be something like answer of I is equal to answer of I minus 1 multiplied with, among the I minus 1 steps, choose any of the n minus 1 steps where n minus 1 people will die. It was divided by 2 raised to the power I minus 1. That is the total possible combinations of a person dying or a person not dying and so on, multiplied with 1 by 2, because if 6 people were dead among the first 9 steps, then for the 7th person to die there is a 1 by 2 probability of that happening. So this was the formula I got, and it is valid only when I is greater than equal to n. When I is less than n, in that case it's quite obvious that the probability is 0, because we know that the people are not dumb enough to die in the same pit where someone has already died, right? So does it make sense? Okay, so let's move on. Whatever formula we had got, I just used that same formula for solving the problem. I created an answer variable, went for each step from 1 to m. If I is less than n, then I know that nobody would die, so the probability is 0. Like not everyone can die among the first I steps in this case, so the probability is 0. Otherwise, the probability is nothing but it is equal to answer of I minus 1 plus choose n minus 1 steps among the first I minus 1 steps where people will die, divided by 2 raised the power I minus 1, like this, and at the end again divided by 2. So multiplying with 1 by 2 or dividing by 2 is the same thing, and at the end sorry sorry and at the end I'm just printing the answer and so on. So let's move on to the next problem. Crafty coloring easy. So this is the easier version of the problem, crafty coloring. In this problem it says that Alice and Bob are playing a game on a grid with n rows and m columns. The cell of the cell at the interaction of the ith row and the jth column is denoted by I comma j. Initially all the cells are colored white. On a player's turn, first cell uh, first the player will choose a cell I comma j that is colored white. If no such cell exists, then the game ends immediately. Then if Alice turn, then if it is Alice's turn, then all the cells that share a row or a column with I comma j will be colored red. If it's Bob's turn, then all those cells would be colored blue. Formally, all the cells x comma y such that x is equal to I or y comma j will be colored. Note that even the previously colored cells will have their colors overwritten to the new color. We are given a cyclic string S of length k that contains only characters A and B. The string describes the sequence of which character will, of which player will make the move. That is for integer I greater than equal to 1. They are just writing it more formally that uh, on how we will decide which player will make a move. The winner of the game is the player with more cells of the color red for Alice and blue for Bob. If both players play optimally, find the winner or decide that the game will end in a draw. So the game says that there is a grid, there is a grid or a matrix, whatever you say, with n rows and m columns. And yeah, there is a sequence given to us of length k, sequence given to us of length k. The sequence can be something like A B A B A B or A. Anything can happen in the sequence. It's just that A and B both, like the characters would be nothing other than A and B. Now let's say if the character is A, it means that it is Alice's turn. So Alice will choose a cell on the board. Let's say Alice chose, okay, just 1 second. Yeah, so let's say Alice chose this cell, which is initially white. Then all the cells in the same row and the same column will become red. Then it is Bob's turn. So Bob can choose any of the other cells which are not colored yet. All the cells which have already been colored cannot be chosen. So Bob can choose either of these. Let's say Bob chose this. Bob chose this. So he would overwrite these cells as well and color the uncolored cells. Then it would be Alice's turn. So she can choose any cell. Let's say she chose this. Then she would get this. All these cells colored blue, sorry, colored red. Then let's say this is Bob's turn. He has only one choice, which would take on this. And at the end of the day, I think Bob is having more colors than Alice. Alice has only six. Bob is having uh, six and then four more, 10. Bob is having 10 and Alice is having only six. So Bob win. So in this case, the output would be Bob. We have to tell in this way that if both the players play optimally, right now we just randomly chose some cells. But if both of them play optimally, then who would be the winner? Now the first question you should have in your mind is, what can be the optimal turns? What can be the optimal turns for Alice and Bob? Let's say it's your turn and you have a lot of free places where you can place the cells. Then where will you place? Where will you, like, which cell will you choose? So I did spend some time at thinking about it. And what I had observed was it doesn't really matter which cell you choose. If you choose some cell which, like, yeah, let me take another place. Let's say I choose a cell like this one, then all the cells in the same row and the same column would be colored red. So none of us, neither Alice nor Bob, can pick up any cell in the same row or in the same column now. Right? Bob can choose some cell which is in some other row and in some other column. Let's say Bob chose this. Then all of these and all of these would be Bob's. Right? This is Bob's, this is Bob's, this is Bob's, Bob, and so on. You know, then it would be Alice's turn, let's say. Like whose turn it would be depends upon the sequence. Now let's say it is Alice's turn. It doesn't matter whether Alice choose this cell or this cell or this cell or this cell. because whichever cell Alice chooses will intersect with, like, you will color all the cells in the same row with the red color. So since there have already been two cells being chosen by both Alice and Bob, there will be two cells in the same row which are already colored and two cells in the same column which are already colored, right? So can I say that two cells in the same row and two cells in the same columns would be sort of uncolored, and then you will color them with the with your color? Yeah, I can definitely say this. So the problem is more like you can choose um, any cell, because even if I chose this cell other than this cell in the row, I will still have two intersections, and in the column also I will still have two intersections. Since Alice has already colored one, chosen one cell, and Bob has already chosen one cell, so one interaction would be with Alice in the same row and one interaction with Bob in the same row. Similarly for columns. So can I say that if C uh, CNTA was the number of cells which Alice had already acquired, that thing would increment by n plus m minus 1, that is the total number of cells in the same row and the same column, and the cells which Alice had previously acquired, Alice had made one move, so you would have got one interaction, one intersection in the same row and one intersection in the same column. So count of A would be decreased by, let's call this thing as OCCA, that is the occurrence of A, how many times Alice has chosen any cell. So count of A would be decremented by 2 into occurrence of A, and count of B would be decremented by 2 into occurrence of B. This would happen, and then the occurrence of A should be incremented after this, right? Can I say that that's all what is happening? It doesn't matter which cell you choose. This was the main observation in the problem, that it doesn't matter which cell you choose, because whichever cell you choose, it will cover the complete row and the complete row and the complete column. When you cover the complete row, whatever is the number of cells which have been chosen by you or Bob would be uh, rewritten, would be colored again, है ना? And similarly in the same row, whatever cells have already been colored by Bob or Alice would be colored again. So these cells which you had counted earlier for Alice and Bob can be removed, and then you can add the complete row and column to Alice. So you just have to do this thing for minimum of n comma m times, whatever is the minimum of row or columns. Let's say if there are 2 rows and 10 columns in the grid, um, in the first operation, whatever move Bob chose, and then whatever cell Alice chose, both the rows would have been chosen. So all the cells in the grid would have already been colored. And the same thing goes if m was less than n, all the columns would have been uh, completed before rows in that case. So basically, minimum of n comma m is the number of operations it will take for completely uh, coloring the complete grid. So you will make this many moves. In the easier version, n is not too huge. And actually in the easier version, n into m is also not too huge. So even if somebody was not able to make some formula like this, he could have still solved the problem if he had noticed this part that it doesn't matter which cell you choose, it should be just an empty cell. So you could have actually did some brute force approach here, that choose any random cell and color the complete row and the complete column and repeat the same process again and again, and eventually at the end of the day, just look at the number of red cells and the number of blue cells, and if blue is greater than red, then answer is Bob. If it is less than red, then the answer is Alice. And if the blue and red are equal, then the answer is draw. So that's it for solving this problem. Here is my code. First of all, I'm taking the inputs. Then I have been going from I equal to 0 till I is less than minimum of n comma n. That is the number of operations I will use. So S of I mod k will tell me the character A or B whose turn it is. I'm subtracting B from it. So this ID would either be 0 or 1. 0 for Alice, 1 for Bob. Then I'm having these 4 lines of code for doing this part. Basically, these 2 lines of code is doing nothing but um, it is sort of removing the colors from the cells in the same row and in the same column. Then I'm adding the colors in the same row and in the same column. And then I'm incrementing the number of operations which the current guy, that is Alice or Bob, has applied. And after that, depending on the number of cells Alice and Bob have got colored, I'm declaring the winner. That's it for this problem. And in the harder version, the difficult bit would be that n and m can be very large, very huge. That's the only difference. N and m can become very huge now. So the previous approach won't work as we can't run a for loop of minimum of n comma m size. So my approach for the next problem was something like uh, this, that I will have a sequence of k operations, right? After that, when I do the same thing again, and then I will do the exact same thing again and again, I will complete minimum of n by k, sorry, n comma m by k cycles. I will have such this many number of cycles. Uh, it could be like, you might have something like AB. You might have something like AB, 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 AAB, something like this as a sequence. So first of all, you will apply these k operations here. Let's say you are done with these k operations. Then you will again do the same thing and again do the same thing and again do the same thing and so on. So I just try to identify whether I can understand what will happen with the count of A, count of B, occurrence of A, and occurrence of B. With these 4 variables, what will happen after applying the K operations? If I could identify what will happen there, like for the K operations, I know what will happen. Uh, Initially, the count and occurrences were zeros. Then, uh, if I get some A at some place, in that case, I was incrementing count of A, decrementing count of A and count of B with occurrence of A and B and so on. I was doing some 4 steps, right? So I just identified that the 4 steps I'm doing, uh, just like these variables just depend upon each other and nothing else. So if I know the current values of count of A, B, occurrence of A and occurrence of B, and I can, if I could find out some relation of what will be their values after applying these K operations, then I could use matrix exponentiation here. I could just use matrix exponentiation for running these n by n comma minimum of n comma m by k number of cycles in logarithmic time complexity for them. So all I did was just find out some relation and then I did solve it. But uh, I think there is some easier, there is some simpler solution available. I believe there should be some simpler solution possible. There were a lot of submissions for this problem. So I believe explaining matrix exponentiation for this problem for 20 minutes would be a waste of time and waste of efforts. A better thing you can do is just go to the text editorial and read it out. They will have some simpler solution for this problem, and it would be better to solve the problem from there for this problem. My approach, matrix exponentiation, is a lot more complicated than I believe the ideal. I believe it should have been a lot more simpler than what I have done. So, yeah, that's it for this PCD. Thank you for watching and bye bye.